I just wanted to go over these related rates problem again. So let's look at example I. Water pours into a fish tank at a rate of 0.3 meters cubed a minute. That meters cubed is a good indication that we're talking about a volume here. How fast, that's a rate, is the water level rising if the base of the tank is a rectangle of dimensions 2 by 3 meters? So always draw a picture first to see what we're talking about. So here's a rectangle tank, and water's pouring in. That's my volume. My base is a rectangle, and its dimensions are 2 by 3. And going up is the height. So as the water level rises, this is my height, h. So now let's identify the related rates. Water pours into a fish tank at a rate. Here's a rate. We said this is volume. It's pouring in. So I have dV over dt. And we know that that's 0.3 meters cubed per minute. How fast is the water level rising? Rising, well, that would be the height of the water in this tank. So that's dH over dt. It's saying how fast, so we don't know what that is, if the base of the tank is 2 by 3 meters. So given my length is 3 and my width is 2. So I'm talking about volume of a rectangular tank. Volume equals length times width times height. So again, we need a formula relating my V, my H, and what's given to me, 2 by 3. Here's that formula. And my next step is to differentiate. And when I differentiate, I only want these two rates. So I want dV over dt and dH over dt. I do not want L and W. I don't want dL over dt or dW over dt. So I'm going to put the constants that are given to me. So I have volume equals 2 times 3 times my height, which volume equals 6h. Now that I only have this in terms of V and H, right, V and H, I can go ahead and differentiate implicitly. So derivative of V is just 1 dV over dt, since it's with respect to V. Equals, well, 6h is just 6 dH over dt. I'm looking for dH over dt, so I'll divide both sides by 6. Let's go over here. I know dV over dt is this 0.3. I'm dividing this by 6, and this equals my dH over dt. And this guy is it's my height, which is 1 dimension. And what did we say that was again? I've got 0.3 divided by 6. So the final answer is 0.05 meters per second. Final answer. Let's look at the next problem. Water pours into a conical tank. Well, this should say at a height. When height is 10 meters. And radius is 4 meters at a rate. Here's a rate. It's pouring in, so this rate is my volume. So let me try to draw, I don't know, I'll try to draw this cone. And this is my height. Here is my radius. It's pouring in is my volume. And so it gives me the rate. At what rate is the water level rising? At what rate? So again, what are my related rates? Water's pouring in, and it gives me that rate. And it's cubed, so water pouring in is volume. So I know the derivative of volume with respect to time. The rate that this volume is at 6 meters cubed per minute. I get that from here. What's the next rate? At what rate is the water level rising? Well, that's filling up. That's my H. dH over dt. At what rate? So that's my question mark. When, here's my condition, when the level is 5 meters high. That's again my H, when H equals 5. So I've got my related rates. I'm only worrying about A. And now I need to come up with a formula. And so we need to know the formula for the volume of a cube. Remember, any volume is base times height. And in this case, my base is a circle. My height is my height here, my cone. But it's a circle. It's 1/3 pi r squared times the height. So I have this volume formula. I know the next step is to differentiate, but again, I only want V and H. Well, I have a V, an R, and an H. I do not want this R here, so I need to do something. So I know here it says my radius of this cone is 4, and this height is 10. But that changes as the water fills up. Like down here, my radius is smaller, and as it fills up, my radius gets bigger, just like my height gets bigger. So radius is compared to the height. So R is to H, as 4 is to 10. And so I cross multiply, I get 10R equals 4H. I want to solve for R, so I divide by 10, divide by 10. R equals 4 over 10H, or I could write 0.4H. Well, now I have R in terms of H, so I can get rid of the R here and rewrite this as volume equals 1/3 pi. My R is now 0.4H squared times H. Well, now if I differentiate, I have V and H, which is all I want, dV over dt and dH over dt. So let's just fix this more. 1/3 pi, and when I square this, I get 0.16. H squared times H is H to the third. I can now go ahead and differentiate this. Derivative of V is just 1 dV over dt equals, remember this whole thing is a constant. I don't have to multiply it all together just yet, but when I take the derivative of a constant h cubed, I bring the 3 in front. When I bring this 3 in front, 3 to the 1/3 is just 1, and I'm just left with this 0.16 pi. H, well 3 minus 1 is 2, dH over dt. I differentiated. Again, I'm looking for dH over dt. So let's isolate this. So I'm just going to divide this whole thing over. dV over dt divided by 0.16 pi h squared equals dH over dt. And now let's plug in what we know. Well, dV over dt is 6. So I have 6 divided by 0.16 pi. This tells me I'm looking for this when h equals 5. So this is times 5 squared, which is 6 over 0.16 pi times 25. And so on my calculator, I'll go to alpha y equals, I have 6 divided by 0.16 times second pi times 25, and I get this equals 0.477. Did I find it again? So meters per minute. Sorry, meters per minute. The rate, I'm finding the rate at which the water level rises. And so here's my final answer. I hope this helped.